Here we have this function right here, and it's called, has a name for it. It's called the normal probability density function, or for short is PDF. And the mu right here, that represents the mean, and then the sigma represents what we call the standard deviation. And so here's an example. The population of IQ scores, as measured by the Stanford Binet Intelligence Scale, has a mean of 100 and a standard deviation of 15. And so what it means is that the population of IQ scores, the average is 100. Some people will have IQ scores above 100, and some people have below 100. And so on average is 100. And so in the place of mu, we would have 100, and then in the place of sigma, we would have 15. And the function becomes 1 over 15 times the square root of 2 pi, and then exponential e right here. This is e. And so this is an exponential function. It's a special exponential function. And then x minus mu, which is 100, and then dividing by sigma, which is 15. And this is what the graph looks like. It has a bell shape. We call it a bell-shaped curve. And it looks like this right here. And then the mean, as said earlier, the mean is 100. And so right in the middle of the bell curve is 100. And then what the standard deviation does is this. So from the mean, if we go 1 standard deviation right, and then 2 standard deviation, and then go to about 3 standard deviation, and it should be about right here. And then if we go 3 standard deviation to the left of the mean of 100, then it should be about right here. So that's what the standard deviation does. And so now that we know the PDF, or the probability density function of IQ scores, then we can ask questions like this. What percentage of the population of IQ scores is within 1 standard deviation of the mean? Meaning, if we go from 100 and we go 15 above it and then 15 below. In other words, what percentage of the population has IQ scores between 85 and 115. So 85 is 1 standard deviation below the mean of 100. 115 is 1 standard deviation above 100. And so to answer this question, what we would do is just find the area between 85 and 115. So draw the graph and then find the area between 85 and 115. And that will give us the percentage of IQ scores between 85 and 115. And so for a function like this, there is no antiderivative. And so to calculate this definite integral from 85 to 115 here, we have to use some numerical integration method, like the trapezoid rule, or another one similar to trapezoid rule. And so here we have the graph of this PDF right here, of this integral right here. And we want the area between 85 and 115. So this is the area between 85 and 115. And using trapezoid rule, we get about 0.6826. And so what that means is the population of IQ scores between 85 and 115 is about 68.2%. And what that also means is that for the population, about 68.2% of the people have IQ scores between 85 and 115. . And we could also ask similar questions. What percentage of the population have IQ scores within 2 standard deviation from the mean? And so the mean IQ score is 100. And if we go 2 standard deviation to the left of 100 and 2 standard deviation from 100, then we'll get 70 and 130. So the standard deviation is 15, and 2 times 15 is 30. So 2 standard deviation is 30. And so from 100, if we go 30 to the left, then we get 70. If we go 30 to the right, we get 130. And so to find the percentage of the population with IQ scores of 100, that is between 70 and 130, then we need to find the area between 30 and between 70 and 130. So the area between the graph and the x-axis from 70 to 130. And this is what the graph looks like. Once again, this is the graph of the PDF, or the probability density function, which is this function right here. And then this is the area between 70 and 130. And so this area is 0.9545. And writing as a percentage, then we have 95.4%. And so what it means is that the population, like the United States, the people with IQ scores between 70, the percentage of people with IQ scores between 70 and 130 would be 95.4%. And then the last question is, what about 3 standard deviations from the mean? And so the mean of the IQ scores, or the average IQ score, is 100. And if we go 3 standard deviation, 1 standard deviation is 15. So 3 standard deviation would be 3 times 15, which is 45. And so from 100, if we go 45 to the left, then we're at 55. And then if we go 45 above the 100, then we'll get 145. And so we're looking for the percentage between percentage of IQ scores between 55 and 145. And therefore we want the integral from 55 to 145. And again, this is the graph of the PDF with the probability density function, which is this function right here. And then this is the area between 55 and 145. And it'd be 0.9973, or 99.7%. And so the population of IQ scores between 55 and 145 is 99.7%. And so almost everybody has IQ scores between 55 and 145.